Today, today I will talk about polymers obtained from lignite cellulose, based on article of cooperation of University of Stavanger in Norway of Professor Gopal Krishnan Kumar with Mauritius University team with Pratima Gita leadership. Their work is published in International Journal of Chemical Engineering and Applications and is entitled Biotransformation of Lignite Cellulosic Biomass Hydrolysate into polyhydroxyburate biopolymer in Ralstonia eutropha. Now, the reason is seeking the sustainable replacement of conventional fossil fuel polymers and with using of waste and reducing landfilling and lignocellulose recyclability, especially there's a polyhydroxyalkanoates that can be not only by production of pyrolysis, but mostly in dark fermentation and fermentation processes. That is much lower energy requirements, thus more sustainable and more efficient, only much more smaller. But it can be also for algae and many plants, all plants that contain lignocellulose. The Ralstonia eutropha is common microorganism which is gram-negative bacteria, and besides has growing in the bacteria can produce isobutanol, and due to high hydrogen production can be also by the fermentation contain this main hydrogenase is nickel iron, so adding nickel and iron is very good. This is very good potential for production of enzyme, and the addition of this salt can increase activity of this enzyme, growing hydrogen production or other cases of biogas. But we here mostly find the issue of lignocellulose waste reduction and batch fermentation of waste conduction in the time from 0 to 48 hours resulted in the dry cell weight up to 2% and reduction of nitrogen ammonia of fermentation was 17% of wastewater and of liquid cell waste, and then using Industrial pass as carbon source, and the plant of lignocellulose waste was Mauritius hemp, which is called uh, giant green aloe, which is also is Mauritius and our South America plant using for paper production and uh, for ropes, and some has rheumatoid, but it generates some waste that needs to be utilized. Thus was this plant green alga as source of bioglycols in the research. The polyhydroxybutyrate is member of polyhydrocalconate, has thermochemical mechanical properties comparable to polypropylene, but may be used instead of conventional polymers in renewable biomass, which may be first generation feedstock such as maize and peat, but overcast by microbial. And most important is polyhydroxyalconate, and is evolved version. Due to the similarity, they can use in many industrial applications, for example, for food packaging and glass transition of 15 degrees, and is projected in 4 times and 9 times more than traditional, such as polyethylene nowadays due to low processing. But there are plenty of methods and which are science to compare. And first is what is metabolic pathway of polyhydroxybutyrate production, and is metabolic synthesis for precursor generation, monomer synthesis, and polymerization. And precursor generation is carbon source giving to pyruvic acid cycle with some energy generation, and the rest is going to produce monomer for polymer, which comes acetyl reductase produce use ketolase, and then is going to polyhydroxyalconate synthesis, and here was this polyhydroxybutyrate. So this is the general pathway, and excess the certain is dependent of metabolic flow of acetyl reductase that is necessary to find methods which can make more stable, and then making cost less. This is the first. And polyhydroxyalcosinate are categorized into short chain length and medium chain length polyhydroxyalkanoates as per their respective monomer components and carbon atoms. The monomers are composed of 3 to 5 carbon atoms and can be synthesized from bacterial strains such as uh, Alstonia eutropha, and therefore, besides with cooperation with other bacteria, can lead to the polymerization, and therefore is important. And for example, can be very well for example, in masks, which as in Mauritius were used, which were more better than plastic masks during coronavirus and pandemics. The cost of polyhydroxybutyrate per pound is $2.75. So which is 4 times higher than polyethylene and polypropylene. So using them needs to be supported by government as green public procurement policies in case of Mauritius to reduce differences and make them more available. The application of simply sugar for glucose, sucrose, xylose, mannose, fructose is different. An application of glucose can be an energy source. In polyhydroxybutyric and ethanol solution, while sucrose is biopolymer production and carrier for emulsifier, xylose as sweetener and is important for production of biofuels and chemicals. Mannose is dietary supplement in animals and human food. Galactose and fructose can be also for energy and ethanol production. The 5-hydroxymethyl furfural, which is for lignocellulose and lignin and furfural and hemicellulose, are precursors for fuel, resin, and plastic, and can give the nylon polyester even if proper synthesized. So is future for some replacing or conversion, but still very low. So this is the achieve the future which was very highly scientist in documentation to make not only hydrogen as product, but some other products which helps make us independent from fossil fuels. The Blastonia is autotrophic grow, can use variety of many lignocellulose materials, making them more sustainable than other. Has more resistant to toxic compounds. For example, like syngas can be if after syngas for phenol can be in ways. So this product it makes that more favorable in some more for some highly polluted uh, places to be made to be applied for this biopolymer production and utilization. The overall production potential requires inoculum development, inoculation at 24 at 30 degrees, and then is purification of polyhydroxybutyric acid and extraction and the Fourier transport form Fourier transport irradiation techniques are used for quality measuring. In the method for checking this was 250 milliliters Erlenmeyer flask, and the agar slant as nutrient was 20 hours 4 hour all, and then was for a rotary breed in 200 rotors per meters for 18, and then put into to reactors and check with the feed uh, of 5 gram per liters of mm, green algae. Therefore, we choose the cell growth with the light, and reaching after was 50 days of measuring, and 50 days was from 0 to cells the cell dry way initially to 1/6 in the after 50 days. So 46 days give 1 gram per liter increase. And this shows us the waste. The polyhydroxybutyrate yield was 70%. So from biomass, so quite still low, but this is important to make it to check our possibilities, and it is possible, and should be compared with other materials. But in the case, for example, Mauritius, they are solving because green algae is invasive plant that needs to be utilized. So here is an example how green green aloe, sorry, green aloe, not alga. Green aloe is, or Mauritius hemp is important to be utilized, and the application to produce polyhydroxybutyrate is very fine. Thank you very much for listening.